Welcome back. In this video, part 3 of isotopes, we're going to solve another isotope problem where we are calculating the atomic mass or the atomic mass of one of the isotopes. So in the last problem, we used the isotope mass and a percent abundance to actually calculate the periodic table value. This time, the problem asks, or it says, gallium has two naturally occurring isotopes, gallium-69 and gallium-71. What is the mass of gallium-71? So that's what we need to do. So here we're going to use the atomic mass, the average mass, and then our percents. So the first thing we need to do is figure out what is the percent abundance of gallium-71. Now there's only two isotopes, and gallium-69 takes up 60.11%. So together they make 100% of all the gallium. So if we subtract this number from 100, we'll actually get 39.89%. So that's the percent abundance for gallium-71. Now remember, our equation looked like this. It was the atomic mass equal to the sum of the first isotope plus the second isotope. And in here we had the atomic mass, or the isotope mass, 68.9256, times the percent abundance, but the decimal percent, so 0.6011. Now over here we're going to have the same thing, except we have an unknown times our decimal percent, 0.3989. So we can substitute here for our atomic mass the actual atomic mass of gallium, and that's 69.732. Now we haven't been talking about what these units are. There's two possible units. They can be atomic mass units if we're talking about individual atoms, but sometimes this is also known or shown to be grams per mole, and we'll talk about that in a later video when we talk about moles. But for now, the units can be atomic mass units. So once we've got this, we can actually try to get A by itself. That's what we want to do. So since this is an addition, we can subtract this to the other side. So we can go 69.732 minus, now all of this together, 68.9256 times 0.611. That's all equal to, now, A times 0.3989. We still want A by itself, so we can divide this side by 0.3989 and divide this whole side by 0.3989. And that'll actually get rid of it over here, so that all we have is A, or our unknown. This is the mass of gallium-71. So if we calculate this, the mass of gallium-71 is actually 70.94 with some other numbers, 716. And when we talk about significant figures, we can figure out how many figures we can actually keep. We'll usually keep this amount. So it'll be 70.95, we would round up. But that's how we would go about solving a problem like this. So between trying to solve for the atomic mass or the percent, which would be the same sort of procedure, we can also be given all of this and solve for the atomic mass. All right. Well, good luck solving your problems.